Hello everyone, this is Abe Martin. I'm a PhD student at Brigham Young University, and I've had several people ask me recently about how we make drone maps using Terragen for our research. So I thought I'd give a quick demonstration today about how you go about doing that. So we'll start out with an empty Terragen file here. This is just a blank file, and you can go ahead and delete the default terrain here, since we'll be bringing in our own later. And close out the node network. Now the first thing we need is a site that we want to simulate mapping. So let's go ahead and go over to Google Earth or Google Maps. And for this demonstration I just chose a kind of random site, and this is just a gravel pit that looked interesting. So what we're going to need to find some elevation data for this site and also satellite imagery to lay over the top of that data. In this case, I was able to find some pretty high resolution elevation data on the site Open Topography. So you can see I've selected that site here, and we'll go ahead and come down to the point cloud data here. And what we're after is this DEM generation to generate an elevation map for us. I went ahead and left it on the default grid resolution of 1 meter, and I found that the IMG file format works best in Terragen for elevation data. So let's go ahead and download that. We'll also need some satellite data for our area of interest. And I found some satellite data for this through Utah's online aerial imagery database. So we can select the data here, and then we can download that as a GeoTIFF. And I've already downloaded both these files, so I won't download those again. So now we go back into Terragen. We'll go ahead and click on the Terrain tab, add terrain, and then load DEM. This will allow us to load in our terrain data. Okay, here's my elevation data I had downloaded previously. Go ahead and open that up. Now, you probably won't see this elevation data initially when you load it in. That's because it's geo-referenced, and the georeferenced location is on the far side of the planet from where we started out here. What you can do to fix that is click on your elevation shader here, expand the submenu. We can take one of the corners of our elevation here. Let's take the southwest corner. Go ahead and copy that coordinate, and go over to Objects, open up our planet object, and paste those coordinates into the lat long at apex field. There we go. And that has moved the apex of our planet, or our starting location in Terragen, to the location of this elevation data. So now if we right click and do center on object or shader, center on the shader, and we can see that we're having this elevation data showing up here. Now there are some issues with the loading here. Often with a DEM, the values where you don't have data will default to 0, which in Terragen's case is the middle of the planet. We don't really want that. So let's go ahead and go back to our terrain shader here. We'll check this box that says replace no data values, and then let's set those to, let's see, we can see here that our data is at about 1,300 meters. So let's set the no data values to be 1,300. And then we can update that. Now if we go again to center on shader, there, that has a much better view of our terrain. Another couple of things you want to do, if we come back to the main shader tab, you usually want to turn border blending off, since we're trying to represent an actual site here. That'll keep the borders of the your elevation data from being blended. And I've also found that if you change the interpolation method to this over smooth, you find I get less artifacts in my terrain data doing that. Okay, so we have our terrain data in. You can see if we come here that does indeed look somewhat like the site we're interested in. The next thing we want to do is go ahead and bring in a satellite layer. So we come here to the Shaders tab, click on Add Layer. We want a color shader and a geologic image map shader. So go ahead and open that satellite data that we downloaded. This may take a minute to run through all the color bands here. Okay, so the next thing we want to do then is to add a few more objects of interest to this scene. So I'll just give a demonstration of how you can add additional objects to make our scene a little bit more interesting than just the default map. So if we come back to Google Maps, we can see there's kind of a flat area at the top of this hill. Let's go ahead and add a vehicle at the top of this hill here. So coming back into Terragen, what we want to do is go back to Objects and Add Object, and then we want the OBJ reader. Now, one nice thing about Terragen is you can import just about any 3D model as long as it's in an OBJ format. So let's go ahead and put in this semi-truck I found earlier. Go ahead and open that. And then we'll right-click the location we want it to be at, do copy coordinates, and go down here to paste coordinates. And our truck's going to come here. On default, it just shows the bounding box. We can see it's quite large. Let's go ahead and scale that down. A little bit too small there. Okay, that's better. And then if we want to see a wireframe preview, we go up to this little blue box here and click on Show as Wireframe. And here we can move this truck around, rotate it. Okay, so now we have a truck that we're going to be able to see in our UAV mapping flight. We can also add populations of objects. Say, for example, we wanted to add some trees up along this ridge line here. An easy way to do that is with what's called a painted shader in Terragen. So go to this little brush and say Start Painting Shader. This is going to allow us to paint the area where we want our trees to appear. So go ahead and size this brush down a little bit. And we'll go ahead and paint an area kind of along the top of these ridge here where we want some trees to appear. Okay. Now we'll go back to the Object tab, go Add Object, Population, and this time we'll do a TGO reader. I had previously gotten a juniper tree here in a TGO format. We'll open that up. Okay. Then let's move the center of the population here. And we'll shrink that down so it just covers our painted shader. Looks about right. you want to check Use Density Shader, and click the plus button here, go Assign Shader, and select our painted shader that we had just created. Okay. Now when we click Populate, we're going to get a bunch of trees in that area that we had specified. You can go back to the brush and do Stop Painting Shader. Good. So now we've added in a couple objects of interest that we're going to be able to see in our UAV flight. The next step is to plan our flight path. There's a few different ways to do that. You can import basically any kind of flight path you want. You just need a series of camera locations and camera orientations. What I'll demonstrate here is importing a flight path from Mission Planner, which is an open source flight planner for the ArduPilot platform. Now, I've actually already planned a flight path here. What I did was I created a polygon using the Draw Polygon tool, and then in this case I just used the auto waypoint simple grid to generate a series of camera positions that I want my UAV to fly to, and I'm going to simulate in this case. Once I've created this flight path, I want to save the waypoint file. And here I've just saved it as mission.waypoints in my folder. Now, in order to import a camera path into Terragen, we need to put it in a CHAN file format, which is a pretty simple format. It's just a frame number, X, Y, Z camera position, and 3 orientation or 3 rotation angles, and then a field of view. So in this case, I just wrote a short Python script that will take my waypoint file and convert it to a Terragen, to a format that Terragen can read, which is this CHAN file format. So go ahead and run that. One thing you do need to know is that Terragen will take your camera positions in meters, X, Y, and Z, rather than in latitude, longitude. So if you have your flight path in latitude, longitude, you'll need to convert back to meters before Terragen will read your file. So let's add a new camera here in Terragen. We'll call this flight path 1, and we're going to import our CHAN file. Let's import camera position.chan. And we also need to do import z up here. Okay, so we can see that flight path I planned has been imported, and the camera is at the first image on the flight. In the general tab of the camera section, that's also where you're going to set your camera parameters. This will allow you to mimic a specific camera that you're going to have on your UAV. In this case, let's go ahead and put in the camera parameters, just say for the DJI Phantom 4. So we're going to put in the sensor size, and the focal length, or let's put in the vertical field of view. And then we'll auto-calculate a focal length for you here. Okay, so now this camera, if we want to see through that camera, we can go to this button down here, click on flight path 1. This will show us the view from our camera. If we want to proceed along the path, we're going to open up the animation panel under View. And this will show us the view along our camera path. now. We'll go back to the rendering tab. I'm going to add a new renderer to render our flight path. Flight render. And then we're going to go to here's where we can set the image width and height of our output pictures. And you can choose these to be what you like. Usually you want to keep them at the same aspect ratio as the camera you're planning to take pictures with. And beyond that, usually you want to set these to the same aspect ratio as the camera you're taking with, and at or less than the resolution that you're aiming for. You can go for a higher resolution here if you want and simulate more accurately what the pictures you're taking will be like, or you can go for a lower resolution and a faster render time. It just depends on what your aims are with the project here. So we also need to go to assign camera flight path 1, and to mimic the in this case, I'll just set these to, let's do 1000 by 800. Okay, at this point you probably want to try to render a test render or two at low reduced quality and reduced resolution. I've done that here, and it looks like everything is checking out. Our trees are there, our truck is there, our terrain is there, our imagery is there. So let's go ahead and move on to rendering. You want to make sure also that the motion blur box is unchecked. Then we'll go over to sequence output. Here we'll be able to choose the output file name and folder where we're going to render our images to. And we want to set this sequence last to the number of waypoints in our flight, which is 59. Then you'll go to render sequence, and that will begin to render the images for your flight, which can take some time. In order to save some time, I've gone ahead and pre-rendered the images. So here's somewhat some of the output of our flight is going to look like here. You can see these things turned out pretty well. At this point, you'll be able to upload these images to whatever drone mapping program you use, whether that's Agisoft Photoscan or Context Capture, Drone Deploy, Pix4D, or another. To give you an example, I've gone ahead and uploaded these images to Drone Deploy and gotten this result here. One thing you may have to do also is to re-inject the GPS data from your mission into your photos. I've done that using a command line tool called exiftool that requires you just to create a spreadsheet with your file names of your images and then the GPS latitude, longitude, and altitude from your mission waypoints file. Once you've done that, you can then upload those into whatever service you want to. Here I've uploaded these images to Drone Deploy and ran them through their free drone mapping service. Created this output map that, while it's not super high resolution, does give a pretty good idea of the coverage that we can expect from this particular drone flight. Obviously, the more work you put into your Terragen file, the more detail and the higher resolution imagery you render, the better your output's going to look like. It's also very useful to know that in Terragen, you can also output the original geometry of the scene using the micro exporter tool. And this allows you to compare the original geometry to the produced geometry from different flight paths and qualitatively compare the effects of different drone flight paths on your mapping results. Anyway, that's all I had to share for today. I hope that's been helpful to you, and thank you for watching.